I just discovered a niche in manufacturing I never knew existed, and it can save companies billions. Yet some are too scared to use it. I've spent the last 20 years in technology for manufacturers, but it wasn't until I started this podcast that I realized just how much I didn't know. Now I share these with you because chances are, if I'm learning this for the first time, so are you. This is Manufacturing Runs the World. Today I want to share 4 things I learned from Ville Lehtonen, Chief Technical Officer of Real Time Robotics. Things that change how I see the future of automation in manufacturing. What is the origin story behind Real Time Robotics?
Two professors wanted to collaborate on what's the big problem with robotics. And it really is sort of path planning is quite painful. I mean, you remember when robots were like there was even, dance, and it was basically like, hey, you're only actuating one joint at a time. Because this gives you very solid control of where the arms are. Once you start doing what is known as blending, right? And it can be quite difficult to tell where exactly the arm is going to be. You
Right.
gain speed, you lose control, and it takes a tremendous amount of time to program a robot. And it takes about 50 milliseconds for us to solve that cancer. And
Wow.
what's more interesting is that if I have two robots side by side, and I say one of you goes here and one of you goes here, it's still 50 milliseconds and they will never collide. If you use modern tools off the shelf, 1 second is pretty good. It's
Yeah.
fine. That's kind of a normal way to do it. So this is 20 times faster. Typically, it's just one robot. So if it takes 1 second for one robot, and RTR can pull it off for 16 robots in less than 100 milliseconds, it's fast.
I'll admit, before talking to Ville, I didn't even know robot path planning was a thing. Sure, I knew robots needed to be programmed, but I never imagined the complexity of an entire line of articulating robots moving together without crashing into each other. Honestly, it's things like this that make this podcast so much fun for me. Even after 2 decades in the industry, I keep uncovering wild new corners. But even with tech this powerful, Ville showed me the biggest challenge isn't the software or the hardware, it's the mindset.
But then people are like, well, this isn't actually that much faster than it was people. And this is where like things get really real, is we had the full control of those robots. And this is a little controversial. If you're the tech guy at a big car manufacturer, you're like, this is the coolest thing I've ever seen. If you're the operations guy who runs this factory with $4 billion, $5 billion worth of output a year,
Yeah.
and it can be higher than that. We were in one Toyota factory that made over 1 million cars a year. So, how much economic output is that? What's the average Toyota worth? It's 25 grand. That's 25 million. And it's probably more than that. So that's a serious factory. You're now told, hey, do you mind if these kids from Boston take over and start controlling your production line? Your production will go up a little. And you're like, well, what happens if they go bankrupt? What happens if they upload a software release with a bug and stuff collides? Because my economic output might be, let's make it really easy, 36.5 billion a year. So, all right, I'm making 100 million. If you keep me down for a day, that'll cost us 100 million. You cannot guarantee to me that they will never upload a bug. So the operations people were just like, none of this real-time decision making. I don't like it at all.
Right. Yeah, understandably so.
So what happened with the car manufacturers is that we kind of had to pivot a little.
So the tech people were excited, but the operations people, for them, this level of risk is unnecessary. I mean, why risk billions if you're already making billions? So if we're sitting on the cusp of the next industrial revolution, especially with automation and AI entering the manufacturing stratosphere, you have to be bold.
So we rolled out another product, which is Resolver, which basically is a level on top of which uses this engine to come up with these paths, but it's doing this massive evolutionary process on it and is looking for the fastest paths. And by and large, we've improved the cycle time of everything we touch by about 17%. You're like, well, what's that really mean? Is, well, every factory that used to make 1,000 doohickeys an hour can now make 1,200. That's a pretty big deal because you don't have to expend any more capital. Do you have an idea how long it takes to program a robotic cell? How much per robot It's about 300 hours. So if you have a 10 robot work cell, that is 3,000 hours of engineering time. Our goal is to drop that to 30 minutes. Our roadmap is that we can position the robots for you. So the mechanical design kind of goes away too, to a significant extent. And people are planning on, some people are wanting to use our engine against fixture design. So I don't know how familiar you're with fixture design. I want to do something to this part, but I need to hold it in a way like this. People are looking at the engine going like, I hate fixtures. And we're like, we don't really comment on fixtures. And they're like, yeah, but I hate it. But you can validate my designs without me having to go into the real world. Because it takes very long for me to get prototypes. Oh, and if I don't even need to design, if I can have an AI design, I take this AI and your stuff together, and now I just need to run 1,000 instances of both of you, and the thing that used to take me, a quarter in lead time might be done by, the second morning of the project.
Unsurprisingly, Ville told me the boldest manufacturers are in China, where speed isn't just welcomed, it's demanded.
Almost all the companies that think like this, by the way, are Chinese because they're far more forward looking. So when we introduce our product, everyone's like, wow. The Chinese are like, wow, this is really neat. Do you have an API? Because we want to we have software systems. We want our software systems to talk with your
Oh,
software
yeah.
system because I'm like, I really wish the Westerners would talk the same way. One of the Chinese guys thinks you can do it in 24 hours, which I think is kind of a stretch, but still. But
People,
this level of ambition is nice to see. It's just that the most ambitious American line builder I've heard said their goal is 7 months.
yeah,
So like one day, 7 months. Okay.
yeah, that's quite a difference there.
Yes, and this is where I worry that because they feel so complacent. I'm like, give them tariff barriers, and they're going to get even lazier.
So it's not labor cost or even technology that's the gap. It's ambition. The question should be, how fast can we go, or what's possible, not how safe can we play it. This interview with Ville didn't necessarily change my perspective on manufacturing, but it did enhance some things I already thought. There's a world of complexity under the surface of any one factory. Ultra niche software may be the difference between leading and lagging. But the real advantage isn't the machine. It's the culture, the willingness to take a smart risk, the ability to move at the pace of change, which leads me to the one thing I took from my meeting with Ville. The only real competitive edge left in manufacturing is the speed at which you can adapt. And real-time robotics gives you that speed, but only the bold will win. I went into this thinking automation was about tech. I came out knowing it's more about mindset and how fast you're willing to move. If you want to grow in this new era of manufacturing, be bold, go fast, because speed isn't just the future, it's the only edge that matters.